Hey guys, so today we are going to talk about Chapter 14, Section 3, which is right triangles and trigonometric ratios. And the objectives for this section are to find lengths of sides in a right triangle and to find the measures of angles in a right triangle. So notice there is a connection between the trigonometric functions and the right triangle trigonometric ratios that you have studied in geometry. And just a reminder, the trigonometric ratios are SOH, COH, TOA. So we know sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So those are our trig ratios, remember, from geometry. An essential understanding for this section. If you restrict the domain of a trigonometric function to give angle measures between 0 degrees and 90 degrees, the function values are the trigonometric ratios associated with the acute angle of a right triangle. So if you think about when we're drawing a reference angle in our unit circle, this reference angle is always going to be an acute angle between 0 degrees and 90 degrees. And with this right triangle that we formed, using the initial side and the terminal side, we can set up our right triangle like we would in geometry with the trig ratios, with the hypotenuse, opposite, and adjacent. Adjacent. And if we dilate the unit circle, so in this section we're going to be dilating the unit circle by the factor r, and the terminal side of an angle theta will intersect the circle of radius r in the point x comma y, which because we're dilating will become r times cosine theta, r times sine of theta. So we're going to be either enlarging our circle or making it smaller, and because we're changing the radius of that circle, we have to multiply these points to figure out what our x and our y values are going to be. And our key concept, trigonometric ratios for a circle. So now it's not necessarily the unit circle, it could be any circle. So notice now that we have a sine of theta, it's really going to be y over r. So sine of theta equals y over r in this case for any circle. We said before that sine of theta was just equal to y, but that's when we were talking about our unit circle. Remember, the radius for your unit circle is always 1. So in that case, it was sine of theta equals y over 1, which just gave us sine of theta equals y. So because we're dilating now, it's going to have to be over r. So sine of theta is y over r, cosine of theta is x over r, and tangent of theta is still y over x. Then for our reciprocal functions, cosecant of theta is r over y, secant of theta is r over x, and cotangent is still x over y. And to find the radius of a circle, given the x and y values, we're going to use the following equation. R equals the square root of x squared plus y squared. And another way that we can write this would be x squared plus y squared equals r squared. We just square each side of that equation. And notice this equation lines up very similarly to the Pythagorean theorem, which is a squared plus b squared equals c squared. And c squared in our equation represents the hypotenuse. In our circle, the hypotenuse is really the radius of our circle. And note, this is very important. The radius can never be negative. You can never have a negative radius for a circle. And you'll notice this equation here is our distance formula, really, so you'll never have a negative distance. So let's start by looking at some examples, trigonometric values beyond the unit circle. So let's look at our first example. So for a standard position angle determined by the point 8, negative 6, what are the values of the 6 trigonometric functions? So in order, now because we're not dealing with the unit circle, you have to figure out your radius in order to determine all 6 trig functions. So remember, for our points, we have a positive x value and a negative y value, which means that we're going to be in quadrant 4. So 8 and negative 6 is going to be in quadrant 4, just so you remember which quadrant goes where. And now if we label this 8, negative 6, now we're going to look for our radius. So again, to determine the radius, we can use the equation x squared plus y squared equals r squared. So when we do that, we have 8 squared plus negative 6 squared equals r squared. That's going to give us 64 plus 36 equals r squared. 64 plus 36 is 100 equals r squared. To figure out our radius, we have to take the square root of both sides, and r is going to be equal to 10. Again, remember, our radius has to be positive. That's why we're only concerned with positive 10. Our radius cannot be negative 10. So our radius is going to be positive 10. Once we have that, we can start figuring out all our trig functions. So I'm just going to get rid of this. We have a little bit of room over here. So our radius is going to be equal to 10. Our point, which is x comma y, is at 8 comma negative 6. And now to determine all 6 trig functions, let's start with the basic functions first, and then we will talk about the inverse functions. So first we're going to talk about cosine theta, sine theta, and tangent theta. So remember now, because we're not talking about the unit circle, cosine theta is going to be equal to x over r. X is positive 8 over r is 10. So that's our cosine value. I know we are able to simplify this fraction, but for now we're just going to leave it. Sine theta is equal to y over r, which is going to be negative 6 over 10, and tangent is still going to be y over x, which is negative 6 over positive 8. So always figure out your original trig functions first. Then when we talk about the inverse, so we have secant theta is the inverse of cosine theta. To figure out these, all you have to do is flip your fraction. So secant theta becomes 10 over 8. Cosecant theta is the reciprocal of sine, so that's going to be 10 over 6. And again, I like to leave the negative either in the numerator or off to the side. We don't want our negative in the denominator. And cotangent theta is going to be negative 8 over 6. So again, you need, because we're not talking about the unit circle anymore, you need to find your radius in order to figure out all your trig functions, and figure out the original 3 first, and then just flip them to use the reciprocal to find secant, cosecant, and cotangent. So let's look at another example. For a standard position angle determined by the point negative 512, what are the values of the 6 trig functions? So now we have a positive x value, and a negative x value and a positive y value, which is going to bring us into quadrant 2. So we have negative 5, 12. Here's our right triangle, and to determine all of our functions, we need to figure out the radius. So again, we're going to use the equation x squared plus y squared equals r squared. So we have negative 5 squared plus 12 squared equals r squared. So you can keep solving this, or you can realize this is one of our special right triangles. So our radius is going to be 13 when we solve. Once you have the radius, then we can figure out all of our trig functions. So we have cosine theta, sine theta, and tan theta we're going to figure out first. Then we're just going to flip these to figure out our reciprocal functions. So cosine theta is going to be x over r, which is negative 5 over 13. Sine theta is going to be y over r, which is 12 over 13. And tangent theta is y over x, which is negative 12 over 5. Figure out our reciprocal functions. Reciprocal of cosine is secant theta is going to be 13 over 5. Again, the negative you either want it off to the side or in the numerator. Cosecant theta is going to be 13 over 12. And cotangent theta is going to be negative 5 over 12. So these aren't too bad. You just have to figure out your radius first. Make sure your radius is always positive. You can never have a negative radius. And then from there, figure out your original 3 functions, then the reciprocal functions. So let's just look at this one more time. I know we have talked about this a few times before, but it's very important to remember which trig functions are positive in which quadrants. So if we're looking at our values, our point x comma y, in quadrant 1, x and y are both positive, which makes our sine positive, cosine positive, and tangent positive. In quadrant 2, we have negative x and a positive y, which makes sine positive, cosine positive, and tangent, again, is y over x, so that makes it positive over negative, which makes tangent negative. In our third quadrant, our point is negative, negative, so sine is negative, cosine is negative, tangent is going to be negative divided by negative, which makes it positive. And in the fourth quadrant, we have positive x, negative y, so sine is negative, cosine is positive, and tangent is negative. Again, you can remember that acronym, all students take calculus. That'll make it a lot easier to remember which trig functions are positive in which quadrant. First quadrant, all trig functions are positive. Second quadrant, only sine functions are positive. Third quadrant, tangent functions are positive. And fourth quadrant, cosine functions are positive. Okay, so now we're just going to jump right in with some different problems. So we're given that tangent of theta is equal to negative 5 over 4, and that cosine of theta is greater than 0. And with this information, we're going to determine cosine of theta and sine of theta. So first, let's take it one step at a time, and the first thing we have to do is figure out which quadrant we're in. So we know that our cosine of theta is greater than 0. So the quadrants where cosine is greater than 0 are in quadrants 1 and 4. That's where our cosine is positive. We're also told that tangent of theta is equal to negative 5 over 4. So tangent is negative, and in our quadrants, tangent is negative in the second quadrant and the fourth quadrant. So we're able to determine where this angle lies based off of the overlap. So you can see that in quadrant 4, tangent is negative and cosine is positive. That means this angle has to lie in quadrant 4. So now we have tangent of theta, and we know that tangent of theta is equal to y over x. But right now we don't know if our x or our y values are positive. If tangent is negative and cosine is positive, remember cosine is represented by our x value, which means our x has to be positive in this case. So our point is going to be positive, comma, negative, because tangent is negative and cosine is positive, which means that we can write this as negative 5 over 4. So our point is going to be 4 comma, negative 5 for our ordered pair. So with our reference angle, if we draw it out in quadrant 4, we have a right triangle there, it's going to be 4, negative 5. And again, just like we did before, to determine cosine and sine, we have to figure out our r value. So for r, we can do x squared plus y squared equals r squared. So x squared is going to be 4 squared plus negative 5 squared equals r squared. R squared. So 4 squared gives us 16 plus 25 equals r squared. 16 plus 25 gives us 41 equals r squared. So when we take the square root, we get the square root of 41 equals r. Again, we're only talking about the positive because our radius is never going to be negative. So now that we have our r value, we can figure out the cosine of theta is represented as x over r, so that's going to be 4 over radical 41. But remember, we can't leave it like this. We don't want a radical in our denominator, so we're going to rationalize by multiplying by radical 41 over radical 41, which gives us a cosine theta value of 4 radical 41 over 41. And for sine of theta is represented by y over r, so that's going to be negative 5 over radical 41. Again, we have to rationalize by multiplying by radical 41 over radical 41. When we do that, we get sine theta of negative 5 radical 41 over 41. So again, for these problems, first you have to determine which quadrant you're in, then figure out your r value, and from there you can determine whichever trig functions that you need. For our second example, we're given that cosine theta is equal to negative 2 over 3 and sine of theta is less than 1. So first we have to determine where these overlap. So when sine is negative, Sine is negative in the third and the fourth quadrants. And we are told that cosine is also negative. Cosine is negative in the second and the third quadrants. Again, you can determine this by using the acronym. All students take calculus. So cosine is negative in the second and third quadrants. Sine is negative in the third and the fourth quadrants. So these overlap in quadrant 3. So we know that our theta is going to be in quadrant 3. Now we're told that cosine of theta is equal to negative 2 over 3, and we know that cosine of theta is represented as x over r. Again, we know that our radius can never be negative, so in this case our x value is going to be negative and our r value is 3. So in this case we know r is equal to 3, we know that our x value is negative 2, now we have to figure out our y value. And because we are in our third quadrant, we know that our y value is also going to be negative. So to figure out y, we can use the same equation, x squared plus y squared equals r squared. Now we're just looking for y rather than r. So x squared is going to be negative 2 squared plus y squared equals 3 squared. So we have 4 plus y squared equals 9. Subtract 4 from both sides, we get y squared is equal to 5. Take the square root of both sides, and we have y is equal to radical 5. So we have y equals the square root of 5. Like I said before, we know because we're in the third quadrant, our x and our y values both have to be negative. So our y value is going to be negative radical 5. So now I have my r, I have x and y, and we can determine the missing functions. So we're looking for tangent of theta. Tangent of theta is equal to y over x. So that's going to be negative radical 5 over negative 2. Negative over negative becomes positive, so we have radical 5 over 2. For cosecant of theta, remember cosecant is the reciprocal of sine, so that's going to be r over y. R is 3 over y is negative radical 5. Now we have to rationalize, so we're going to multiply by radical 5 over radical 5. When we do that, I'm just going to move my negative up to the numerator as well. We have negative 3 radical 5 over 5. So we have our tangent of theta is radical 5 over 2. Cosecant of theta is negative 3 radical 5 over 5, and we're done. We're going to do 2 more examples like this, and that's it for this section. So for our next example, we're given that cotangent of theta equals 4 over 7, and cosine of theta is less than 0. So again, we're going to start by determining which quadrant our angle is in. So we have cotangent of theta equals 4 over 7. And remember, cotangent is x over y. So in order to have a positive cotangent, that means either x and y are both positive or x and y are both negative. And that happens when x and y are both positive is quadrant 1. X and y are both negative is in quadrant 3. So that's the only way we can get a positive cotangent. And we have that the cosine of theta is less than 0. So cosine is less than 0 in quadrants 2 and quadrant 3. So notice we overlap in quadrant 3, which means that our angle has to be in quadrant 3. And in quadrant 3, both of our x and our y values are negative. So we're going to have negative x, negative y. So our point based off cotangent is going to be negative 4, comma, negative 7. Now from here, we're going to figure out our r value. So again, r is x squared plus y squared equals r squared. So we have negative 4 squared plus negative 7 squared equals r squared. So 16 plus 49 equals r squared. 16 plus 49 gives us 65 equals r squared. Take the square root of both sides, and r is going to be equal to radical 65, or the square root of 65. Again, your r value cannot be negative, so that has to stay positive. So our point is -4, -7. Our R value is radical 65. And using this information, we can determine the cosine of theta and the sine of theta. So cosine of theta, again, is x over r. So that's going to be -4 over radical 65. You always have to rationalize if there is a radical in your denominator. When we multiply top and bottom by radical 65, we get -4 radical 65 over 65 for the cosine of theta. And for sine of theta, we have y over r, so that's going to be -7 over radical 65. Again, we have to rationalize, so you multiply numerator and denominator by radical 65, and that becomes -7 radical 65 over 65, and we're done. So those are cosine theta and sine theta based off of the information that we're given. And the last example for this section, we're given secant theta equals -5 over 3, and tangent of theta is less than 0. So we're starting by figuring out which quadrant we are in. So when tangent of theta is less than 0, tangent is less than 0 in quadrant 2 and in quadrant 4. We also know that secant of theta is -5 over 3, and remember secant is represented as r over x. And the one thing that we know for sure is that r can never be negative, so r is going to be +5. And which means that our x value is going to be -3. So secant is negative, and secant, remember, is a reciprocal for cosine. So where cosine is negative is quadrants 2 and 3. Our points overlap in quadrant 2, which means we have a negative x and a positive y value. So now to find our y, we're going to do x squared plus y squared equals r squared. So we have -3 squared plus y squared equals 5 squared. So we have 9 plus y squared equals 25. When we subtract 9, we get y squared equals 16, square root of both sides, and y equals 4. And again, because we're in the second quadrant, we know that our y value has to be positive. So we have an r value of 5, and our point is going to be -3, +4. Now, using this information, we can determine that tangent of theta is going to be y over x, which is 4 over -3, or we're going to write it as -4 over 3. We don't need to rationalize because we don't have a radical. And sine of theta is equal to y over r, which is going to be 4 over 5. And again, we don't have to simplify, and we don't have to rationalize, so we're done. So we have a tangent of theta as -4 over 3. Sine of theta is +4 over 5. So again, for these problems, first you have to figure out which quadrant your theta lies in. Then you have to either solve for your r value or solve for your x or y value, depending on which trig function that you are given. And then use all of that information to determine the missing trig functions. And that is it for this section. A couple of things to remember that's important for this section. In right triangle trigonometry, the value of one trigonometric ratio determines the values of others. So as long as you have one, you can figure out the others. And the radius is never, ever negative. Very important. You cannot have a negative distance, so your radius is never going to be negative. And that's it for this section. Your homework is a worksheet which is posted on Google Classroom. If you have any questions, please feel free to email me. We're almost done with the year, so the next couple of assignments are just going to be small homework assignments. Your last big grade for the year is going to be the marking period 4 project. If you have any questions on your grades, please feel free to email me as soon as possible. Have a good day and good luck.